Hello everyone, today we are starting with Unit 7. So for today, we have a mechanical device is used to launch a potato vertically in the air. The potato is launched from a platform of 20 feet above the ground. So that's going to be some important information. 20 feet above the ground. With an initial vertical velocity of 92 feet per second. The function h of t equals negative 16t squared plus 92t plus 20 models the height of the potato over the ground in feet t seconds after launch. Here's the graph representing the function. So we have our graph over here. You can see we have height labeled on this side and time labeled down here. So for each question, we want to be prepared to explain our reasoning. What is the height of the potato 1 second after the launch? So we can look at 1, go up on our graph and see that point is right here. So we need to make sure we understand our scale. So we have 0 down here, then a tick mark, and then 40. So that means this tick mark has to be 20. So this would be 60. This would be 100. So that is the height of the potato after 1 second. So we could say 100 feet. Number 2, 8 seconds after the launch, will the potato still be in the air? So if we follow this path, it starts at that 20 off the ground, goes up, comes back down, and this is at 6 seconds. And then 8 seconds is all the way over here. This bottom part here is representing the ground. So the potato can't go through the ground. So will the potato still be in the air? No. It will not, because this is the point when the potato hits the ground. So it is no longer in the air. Will the potato reach 120 feet? If so, when will it happen? So we're looking at 120 feet over here. We can look across and see, does our graph touch that height? Yes, it does at these 2 points. So we can say yes. And then we can look at our graph and look down at the x-axis to see what those times are. So that's about 1.5 seconds. And this one is a little sooner, so maybe 4.25 seconds. Somewhere around there. We know it's between 1 and 2 and somewhere between 4 and 5. And if you want to say like 4.3 or something like that, that is also fine. And then last question, when will the potato hit the ground? Whenever we see something like that, we're looking at when is my height 0. So height is 0 right here on that x-axis, and we can see that it hits the ground there at 6 seconds. Okay. Example 1, we have the flying potato again. So we're talking about that same equation. Okay, negative 16t squared plus 80t plus 64. Okay, this is our equation for this situation. And our first question says, what equation would we solve to find the time? Since we're finding the time, we're looking for a value of t at which the potato hits the ground. So what is the height when something is on the ground? The height is 0. So that means this is my output. So we need to plug that in for the output of our equation. So all we're asking here is to find the height, or find the time, the equation for when the potato hits the ground. So we would just say 0 equals negative 16t squared plus 80t plus 64. So to find this height, we can look at plugging in some different values for t. So I'm going to go ahead and do that on the calculator. We're just looking for any values of t that we could plug in to see how close we can get to 0. So we have our equation, and we're just going to plug in some different values of t. So I'm going to start, I don't know, by picking 3, maybe. Okay, we're just going to see where that puts us. Then we have plus 80 times 3 plus 64. So that gives me a height of 160, and we're trying to get that height to be 0. So if we go up and highlight the equation and hit enter, it will copy it down. So let's try 4 and see what happens. 128. So this is lower, which means my potato is getting closer to the ground. So let's try 5. 64. So now we're even closer. Let's try 6 and see what that gives us. Negative 32. So because we go from 64 feet at 5 seconds to negative 32 at 6 seconds, we know we hit the ground somewhere between 5 and 6 seconds. So let's just try 5.5 to see what that gives us. We're at 20. So we're pretty close. If you want to keep trying other decimals, you can, but we're just trying to look to get as close to 0 for that output as we possibly can. So we could say for our answer, between 5.5 and 6 seconds. Okay, right now we're just trying to estimate and get as close as we can. Example 2, we have the expressions p times 200 minus 5p and negative 5p squared plus 200p to find the same function. The function models the revenue a school would earn from selling raffle tickets at p dollars each. At what price or prices would the school collect $0 in revenue from raffle sales? So again, we are taking that equation. You can use either one. If we have negative 5p squared plus 200p, we are setting that equal to 0. So we just want to try to plug in some different values for p to see when do we get 0. So the first one that we could try, or that you could guess, is if we sold the tickets for nothing, right, we wouldn't make any money. So negative 5 times 0 squared plus 200 times 0 does give us 0, right? If we're not selling them for anything, we're not going to make any money. But there's also going to be a maximum price where people won't buy them. Okay, so we could sell the tickets for too much money, no one would buy them. So maybe I'm just going to guess, let's try $15 and see where that puts us. So I'm just plugging in 15 for both of those values. 1,875. So that means we'll make a profit or revenue. We'll make the revenue of $1,875. So that is good, right? We want to get down to 0. So maybe let's try 20. What does that do? Now we're at 2,000. So we're still going up. So that means my number needs to get even larger because we're still increasing. Okay? So I don't know, let's try 30, see what that does. 1,500, so now we're coming back down. Let's try 40. Okay, so I'm just guessing and checking some values and looking at how those output values change. Okay, so now we're back down at 0. So if I sell the tickets for $40, we would also not make any revenue in that case because they would be too expensive. So our answers would be $0 and $40, okay? $0 would be not enough money and $40 would be too much money. The school staff noticed that there are 2 ticket prices that would both result in a revenue of $500. How would you find out what those 2 prices are? So we don't need to technically figure out what those are right now. We just want to talk about how could we find out what those prices are. So there's 2 ways that we could do it. We could take those equations that we have, p times 200 minus 5p And our other equation, negative 5p squared plus 200p, right? That's the same equation, just written differently. And similarly to how we set that equal to 0, we could set that equal to 500 and just try some different numbers and figure out when will we see 500. The other way is we could graph and look for a y value of 500, right? Those are the only two ways we know right now, is just trying some different values into our function or graphing. So as we go through this unit, we'll talk about some different ways that we could find the answers to these questions.